Welcome to the third mini lecture in Module 3, Measures of Central Tendency and Variability. In this module, we're going to continue to talk about variability. I'm going to go over the second standard deviate example. We're also going to cover variance and then look at graphing the standard deviation. So for the second example with anesthetic number 2, this is the same data that was covered in the second mini lecture. We're going to first do the deviation score calculation. Recall that the mean is 21.3 minutes. Our values of x in this table represent the different values for the duration of anesthetic number 2. And for calculating the standard deviation, we need at first the deviation score, which is each of the values minus the mean. So for this first one, it's going to be 0 minus 21.3. Remember, keeping the negatives here is important, so it's minus 21.3. The second value is going to be 0.8, 0.8, 0.3, and then 23.2. And as I said with the first example for this, if we sum up this column, because it's each of the values minus the mean, the sum of this should be equal to 0. And that isn't very informative at all for us to figure out how far the values are from the mean. So what we do to alleviate this is to square each of these deviations. So we can complete this table. And then finally we sum them up. And the sum here is 993.30. We can take this information and put it into our calculation of the standard deviation. And our calculation for the standard deviation, remember, is S hat is equal to the square root of the sum of our deviations squared over n minus 1. The value that we have here is our numerator, so it's going to be square root of 993.30. N is the number of observations that we have here, which is 5. 5 minus 1 is 4, which is equal to the square root of 248.2325, which is equal to 15.758. Remember, our units here are minutes. So that's our calculation using the deviation score calculation. If we use the raw score calculation, we will also end up with the exact same value, and you can work through that on your own. We can see that with this standard deviation of 15.758, that this is much higher than what we found for anesthetic number 1 that had a standard deviation of 1.351 minutes. And again, this is reflecting the fact that anesthetic number 2, even though the mean values and all those values of central tendency were similar, or exactly the same, that the deviation and the variation calculated through the standard deviation is different. We can also look at variance. When we look at variance, it's just the standard deviation squared. So variance has the symbol for the population of sigma squared, or S hat squared for a sample. So for anesthetic number 1, it would be 1.351 squared, which is going to end up being 1.875 minutes squared. So we have to keep in mind what our actual units are. And for anesthetic number 2, it's going to be 15.758 squared, so 248.325 minutes squared. So variance, because the units are different, right? We would have a mean that would have the units of minutes and the variance in minutes squared. That's a little bit confusing to sort of work with. So variance isn't often used as a descriptive statistic. The preference is typically standard deviation, but variance is good for inferential statistics that we'll be using later on. So like I said, standard deviation is often used as the standard for looking at variation, and often you'll see it plotted in graphs. So if we wanted to plot our data, where we have our anesthetic, and we have anesthetic number 1, anesthetic number 2, and we have our different values here. Right, so this is duration on our y-axis, and we know that the means for these are the same, right around 21.3 estimated there. And we know for anesthetic number 1 that our standard deviation is 1.351. So we go from our mean value of 21.3 and add the standard deviation of that for our upper value, so that's going to be at about 22.65. And for the lower value, it's 21.3 minus 1.351, so it's going to be at just under 20. Then for anesthetic number 2, we'll draw our standard deviation bars here. So our mean again is 21.3 because they're the same. This time our standard deviation is 15.758, so we're going to add that to 21.3 for our upper bar, so that's going to give us 37.0. And then for the lower bar, it's going to be 21.3 minus our standard deviation of 15.758, so that's going to give us a value of 5.5. So here you can see that despite the fact that the mean values for anesthetic number 1 and anesthetic number 2 are the same, that the variability around those is very different.